this video, what I want to do is I want to talk about the laws of logic. I want to talk about the notions of statements and arguments. And then finally, I want to talk about informal fallacies of logic. All right, the first thing I want to talk about is the notion of the so-called laws of logic. Now, when it comes to the history of describing logic in the so-called Western tradition, the first person to really articulate various features of logic with a great kind of specificity was Aristotle, who lived in the 4th century BCE. And so Aristotle identified 3 fundamental principles of logic. What he means by laws of logic are, here's the 3 fundamental things you have to accept, period. And there's kind of an insinuation here that everybody accepts these. There's no way that you could do any kind of logical reasoning without accepting these principles, these laws. Therefore, everybody believes in them, and that even if you're going to try and refute logic and say, here's how I'm going to disprove logic, you couldn't really do so in any meaningful way without accepting these principles, is what Aristotle is getting at, and his successors. And this is echoed in some other logical traditions in other non-Greek societies as well. You kind of see elements that are like this in, say, the Nyaya Sutras by Akshapada Gautama in India and other places. But here, in the Greek tradition is what's most well known in the so-called Western tradition, so that's why I'm going to stick here. And he says these things pretty succinctly and in a threefold way. So here are the 3 basic laws of logic. The first one is the law of identity. And this one is probably the most simple, and here's what Aristotle means when he says these things are obvious. The law of identity is simply that a thing is the same as itself. What does that mean? It really is as simple as it sounds. So here's a quote from Aristotle's Metaphysics that I have here. Now, to ask why a thing is the same as itself is no question, because when we ask the reason of a thing, the fact must first be evident that, for example, when we say something like the moon suffers an eclipse, and because it is itself, is the one explanation and reason which applies to all questions such as why is a man man, or why is a cultured person cultured. What Aristotle's saying here is that when we have meaningful language, the law of identity is obvious. When I say the moon has an eclipse, what am I talking about? I'm talking about the moon and not something else. So that when we use language, when we refer to, especially nouns, but it could be verbs and adjectives as well. The green pen. What do you mean by green? I mean green, not some other thing, blue or red. When I say pen, I mean pen and not something else. Now, sometimes we can agree to talk in like a code, okay? And we'd be like, when I point this green pen here and I say, the blue pen, and maybe blue we're using as a code word for green for some reason. Sometimes this happens. But basically, when we're talking about something, we're talking about that thing and not something else. This is and Aristotle says this is an obvious feature of language, that when we're talking, when we're communicating, we mean what we say, and we're referring to the objects that we say that we're referring to and not some other thing. And he says this is super, super obvious. When I talk about something, I mean what I'm talking about. You have to accept that. You can't just someone say something and go, oh, you must be talking about this other thing. Well, they're talking about this, or I'm talking about this. So that's the law of identity. Something is itself and not something else. Water is water. The moon is the moon. I am me. All right, the next one is the law of non-contradiction. Now, this is basically a variation on the same theme. So if the law of identity is true, these other 2 laws of logic are sort of corollaries. That is to say, they should also be obvious if the law of identity is true. So the law of non-contradiction works this way. A thing cannot both be and not be at the same time and in the same sense. So I'm going to read a little bit of this from Aristotle here, not the whole quotation, but that way you can see the context of where it's coming from. Aristotle says, clearly then, it's a principle of this kind that is the most certain of all principles. Let us next state what this principle is. It is impossible for the same attribute at once to belong and not to belong to the same thing and in the same relation. So something can't both be and not be at the same time and in the same sense. That's a contradiction. Now, sometimes we'll use the word contradiction to mean something being inconsistent. So let's say, Bob is hardworking, a hardworking person, but he's having a lazy day. Well, Bob is both hardworking and lazy. That seems to be a contradiction. Or sometimes we do this with politics. Someone's a Republican, but on this view they're kind of liberal. That's a contradiction. Or someone's a Democrat, but on this point they're conservative. That's a contradiction. That might be inconsistent, but it's not necessarily a contradiction. A contradiction is saying something and then explicitly saying the opposite. Okay, it'd be like me saying, for example, at the time of me doing this, it happens to be Sunday. To say today is Sunday and not Sunday, that's a contradiction. All right, to say something and immediately the exact same thing with a not or a negation in front of it, that's what a contradiction is. But Aristotle qualifies it. He says, at the same time and in the same sense. So something can't both be and not be at the same time in the same sense. So I could say, for example, let's say I'm in a classroom, it's 8 o'clock in the morning, I'm super tired. There's a sense in which I can say, I'm here, but I'm not here. Is that a contradiction? Well, it might look like one at first glance. But what's going on there is probably I'm talking about here in the first sense, meaning my physical presence, and here in the second sense, meaning my mental presence. So I'm talking about two different senses, so that's not a contradiction, even though it may look like one. Or the notion of time. For example, right now I'm in my office, but at other times today, I won't be in my office. So today, on this Sunday, I was in my office and I was not in my office. That's a contradiction. No, it's not. Okay, because of the notion of time. Something can't both be and not be at the same time in the same sense. I can't both be in my office and not be in my office at the exact same time. That's the issue with the law of non-contradiction. And so with contradictions, a contradiction is an explicit saying of opposites. Okay, sometimes we think things that are different are opposites. That's not the case, as we'll see in the next law of logic. So the next law of logic is actually the law of excluded middle. This is that either a proposition or a statement is true. We'll talk about what propositions or statements are, basically something that we can say that's true or false, or they're not. So that's why he says here at the beginning of this quotation from the Metaphysics, nor indeed can there be any intermediate between contrary statements. But of one thing, we must either assert or deny one thing, whatever it may be. So for example, earlier I said today is Sunday. Now, if I take the law of identity, when I say Sunday, I mean Sunday and not something else. If I take the law of non-contradiction, it can't be the case that it's both Sunday and not Sunday. That would be a contradiction. Unless I mean something else, but maybe I'm looking at some other kind of calendar. Oh, it's technically not Sunday on the Gregorian versus some other calendar. The law of excluded middle says either it's Sunday or it's not. So that's not the same thing as saying it's Sunday or it's Monday. Monday is a different day. Monday is not the opposite of Sunday, because it could be, if I say Sunday or it's not, it could be Monday, it could be Tuesday, it could be Wednesday, it could be Thursday. There are 6 other options. So Monday is not the opposite of Sunday. Tuesday is not the opposite of Sunday. What's the opposite of Sunday? Not Sunday. And so the law of excluded middle says there's no middle ground between a statement. Either something's true or it's not. You've heard people say, what's going to happen when you go to the game this Sunday? Well, we'll win or we won't. Yep. Law of excluded middle. You might be thinking there, well, we tie. Well, if you tie, did you win? No. So there's a sense in which either you win or you don't, in terms of being the victor. Aristotle says there's not a middle ground. Now, some logicians, some scientists, some mathematicians object to this one the most. They say there's instances where this is not actually the case. I don't want to really get into that here. Simply, I want to say at this point, the law of excluded middle, the law of non-contradiction, the law of identity, Aristotle says, listen, to do any conversation you've ever had assumes these principles. I'm not just talking about doing work in math or work in logic. Anytime you've ever talked with anybody else about anything, you're assuming, so says Aristotle, all these principles, that when you're talking about something, you mean what you say, you don't believe that opposites are true, okay, explicit opposites. That's what I mean by contradictions there. All right, it's both, like we might say, I'm happy and sad. Is that a contradiction? No. I'm happy and I'm not happy in the exact same way. That would be a contradiction. Okay, like I said, inconsistency is fine, contradictions are not. And law of excluded middle, something's either true or it isn't. Okay, there's no middle ground. That's what the law of excluded middle is. So for the sake of your first quiz, it's not that I want you to know the nuances of all these for the last 2,500 years. Just be able to recognize them, which is to say, know that, when I say the law of identity, which one am I talking about? Am I talking about something is the same as itself? Am I talking about something cannot both be and not be at the same time in the same sense? Or am I talking about a proposition is true or its negation is true? So if you can at least identify the names with their technical definitions, you'll be good. But this is also basically to help you understand what's going on in logic. So that's the basic framework, according to Aristotle. Everything else rests on that. So Where do we go from here? Now there's some particular things I want to get into in logic. Notions of arguments, statements, different kinds of logic. Let's get into that. So the next thing I want to do is talk about the notion of arguments and statements, at least in the context of talking about logic. So what do I mean by an argument? What do I mean by a statement? You've probably heard the words valid and invalid and sound. That's a strong argument, that's a weak argument. What do all those things mean? Well, in order to get to that, let's start by talking about the different kinds of logic. Here's the three most basic species of logic: deduction, induction, and abduction. All of these come from the Latin word ducere, which means to lead. Like a duke, where duke is like a leader. These each mean to lead in some different way. So deduction literally means to lead down. Induction, to lead into. Abduction, to lead away. You'll notice there is no seduction or seduction on the list, which means to lead astray. That's not logic. That's just cheating. So that's not on this list. Occasionally I'll get someone do a fill in the blank on these questions, but there is such a thing as seductive logic. No, there's deduction, induction, and abduction, aka deductive logic, inductive logic, and abductive logic. The problem is these are all different kinds of logic, and they have different criteria, and they do different things. So the main one that we're going to talk about in this course, like 99.9% of what we're going to do, is deductive logic. You've seen it before. It's the most basic form of math, or as the British say, maths, based on the axioms that we have in place. So deductive logic is where you have logical arguments, and I'll talk more about what arguments are here in a moment, which can be measured in terms of validity and soundness. Basically, if the premises are true, it's impossible for the conclusion to be false. If you got all your material together, you know what the answer is going to be. And so, for example, on standard axiomatic systems, if I say, what is 2 plus 2, or I put it in an algebraic way, I say 2 plus 2 equals x, solve for x, or, what does 2 plus 2 equal? What's the answer? Well, assuming we're using standard axioms, the answer is 4. Could it be 5? Well, in a certain sense, yes. I don't want to get into that here, right? It could be based on different axiomatic systems, depending on what we mean by 2. But I think on the standard way that you learned it in elementary school, when I say 2 plus 2, what does it equal? The answer is going to be 4. Now, you might do some equivalent of 4. You might say, oh, it's, 16 over 4 as a fraction. Well, that's the same thing as 4 if you want. You're just trying to get fancy about it. Basically, deduction works this way. If you have all the stuff together, there's no way that your conclusion could be wrong. 0% chance. If you know what 2 is, based on the system you're using, and you say 2 plus 2, you know it's going to be 4. Okay, another example, deductive logic, geometry. I was using arithmetic there, and algebra, geometry. If I say a triangle has 3 sides, and then I see a figure that has 3 sides in 2 dimensions, could it be a square? Could it be a circle? No, it's a triangle. Okay, that doesn't mean you know whether it's isosceles or equilateral or right triangle. You don't even need to know those things. Just listen. If it's got 3 sides, it's a triangle. If it's got 8 sides, it's an octagon. If it's got 4 sides, it's a quadrilateral. It might be some other. You might be thinking, oh, it's a square. Maybe, maybe not. But we can at least do that. Like, I think the easiest one there is if it's got 3 sides, it's a triangle. There's no way we could be wrong. Okay, what if it has 3 sides and it's a square? There's no 3-sided squares. There's no round circles. There's no circular squares. So the way deduction basically works is if you've got all the data, there's no way you can be wrong. Like 0% chance. Okay, assuming you're doing everything right in the system that you're using. That's one kind of logic, and we're going to focus mainly on that one. Okay, if we've got the right stuff going in, we can get the right stuff going out. But that's not the only kind of logic that there is. There's some kinds of logic which it's possible to err, to make mistakes. There's a certain sense in which we can do that in deduction too, for different reasons, but not based on the premises that we have or the information that we've got going in. So inductive logic, or induction, which literally means to lead into, is a kind of logic where arguments are constructed based on a given sample, and then we generalize or universalize from those instances. So one example of this would be like polling data, when people interview people and say, who's going to vote for whom, and then we say, okay, 90% of the people we interviewed say they're going to vote for this person. We can say, oh, this is the likelihood or the probability of this going to be happening. Okay, so that's inductive logic, where we're making probabilistic generalizations based on samples that we have. A lot of science is done this way, like meteorological science is done this way, based on what we understand about pressure systems, based on hurricanes that we've had in the past. We say this is the way that, based on the the various instances that we've had happen in the past. This is the way we predict this is going to happen, but it's a lot more flexible. Same thing with polling. We polled, we think here's what's going to happen, and then I think people saw that happen in the 2016 election. Here's what we think is going to happen going in terms of the polling. That didn't happen that way because it's fallible. That is, it's possible to make mistakes even based on good data. And we say what makes an argument strong in inductive logic is that you have lots of data, you have lots of instances to support your position. An example of a weak argument in inductive logic or in statistics would be like, I interviewed one person, they said they're going to vote for this person, so I say 100% of people interviewed say they're going to vote for this person. Weak, because I didn't have a lot of instances to back on what I'm saying. Whereas a lot of, say, laws of physics have this kind of inductive backup. How do we know things like, how do we know if water is going to freeze at 32 degrees Fahrenheit? Well, because it's been measured multiple times that it will do that. Now, there might be counterexamples where it doesn't, based on, say, altitude or pressure or all kinds of other features. We haven't been every single instance in the universe where water freezes at 32 degrees Fahrenheit. We can say, based on, hey, there's a whole bunch of instances where that's confirmed. So we can say, listen, if it gets down to 32 degrees, it's probably going to freeze. That's the way induction works. High likelihood we're able to make declarations about things based on data analysis. But it's probabilistic. It's not definite. We don't know with the same kind of certainty. Like that whole triangle has three sides. I'm looking at something with three sides. It's a triangle, 100% certain. Apodectic certainty, like you can't doubt it. Inductive logic, you can have high probability. Okay? 99% likelihood even. There's still a chance that you could be wrong. Okay, that's inductive logic. Abductive logic, on the other hand, is where we abduce, we lead out. So abduction is where arguments are made as likely hypotheses to explain existing conditions. Okay, so what we do is in abduction is we look at a situation and we think to ourselves, what made this happen? Now, like induction, it's possible for us to be wrong or mistaken much more easily than, say, in deduction. We might be right, but we might be wrong. So there's here, instead of probability with induction, we get necessity or certainty with deduction. We get probability with induction, and then we get likelihood of possibility with abduction. So what do I mean by that? Well, like criminal science is abductive, like detectives solving crimes. You know, you come into a crime scene, there's a murder victim on the ground, they've got a bullet hole in their chest. If you're a detective, were they stabbed? Maybe. But probably they were shot with a bullet, with a firearm. Okay, well, maybe the bullet materialized in their chest somehow. Maybe. Or it's more than likely that what happened was, and there's some inductive reasoning going on here too, that they were shot. So what you do in an abductive situation is you try and reason backwards from, okay, here's what I see, what made this happen? So criminal science is this way, like what made this happen? And we've seen it, that can be wrong. Have people been put on trial and convicted for crimes they didn't commit? Yes. Okay, and vice versa too, but that's not my point there. Medical science is also often abductive. So someone comes in with symptoms and you try and reason backwards. Oh, they've got these symptoms, they must have this. Oh, they didn't have that, came back negative, I guess we're going to have to do tests on something else. Medical science, we don't have an uproar over, oh, you said I was going to have this and I didn't. Maybe, based on the symptoms, we try and make abductions to figure out like what could be causing these symptoms. So that's also abduction as well. We do this often. If you came into your home, like you came in the front door and all your furniture and all like your television, everything was gone, I think it would be a wise abductive reason to think, oh, I've been robbed. Maybe there's other possibilities. Maybe someone was just like, no, I'm replacing all your stuff with better stuff. I'm just holding it for a while. But if you came home, like it's possible maybe you were moving and it was a surprise or someone was getting you new furniture or whatever. All those things are possible. But abduction is where we try and say, when we come into a situation, we observe it. What made this happen? What are the conditions that made this possible? Okay, like in the case of coming home. Hey, all my stuff is gone. I guess new stuff's coming. Okay, from rooms to go or what have you. Probably not. You've probably been robbed. A lot of science is also abductive here. So abductive reasoning, like when geology looks at various layers of, or stratifications of rock layers in the earth and says, well, then the earth must have been like this in the Pleistocene or the Pliocene or the Miocene or the Eocene or the Oligocene and so on. Okay, they're able to look at those things and say, here's what was going on then. Okay, here's what caused the Cambrian explosion. Scientists do this all the time. Astrophysicists will say, based on the way the universe seems to be expanding now, we can extrapolate backwards
using abduction and figure out if the universe is like this now and it's expanding, we can rewind the universe and see what it would have been like billions of years ago. Now, since that's abductive, it's possible that it's wrong. That doesn't mean don't trust it. It doesn't mean never abduce or induce. It's just that it's liable to be mistaken. We don't have the same kind of certainty as we do with deduction, like a triangle having three sides. There's no way we mess that one up. Induction depends on how much data we have to collect. And abduction, I think they're based too, our abductive reasoning is only so good as the observations that we have to back it up. A lot of that feedback comes from induction. But the problem with this is, if you ever read Sherlock Holmes, okay, the detective, or you're familiar with the character, Sherlock Holmes refers to all of this, especially abduction, with the word deduction. So, these are the differences between them. Deduction is based on validity and soundness. If the premises are true, it's impossible for the conclusion to be false. Induction is where it's based on samples, and then those samples are universalized or generalized. We take a couple of instances. We say, okay, this happened a couple of times, so we can say probably this is going to happen. It could be wrong. In fact, it's a specific deductive fallacy when we do that. Then abduction is where we say, okay, here's what's going on. What caused this? So like right now, a good abductive argument would be like, okay, you're watching this video right now, so at some point Professor Burris in the past recorded a video in order to make this experience happen right now. That's a good abductive argument. It might be wrong. This could all be a deep fake, and this didn't happen. Maybe, but when we're using abduction and we're trying to reason backward and figure out what made this possible, what could have made this happen. Those are the different kinds of logic that we're going to talk about here. The main one that we're going to talk about and examine from here is deduction.
Okay. Now let's get into some more aspects of deductive logic. So I'm going to define some terms here. So first of all, let's talk about the notion of an argument. So colloquially, we use the term argument all the time to mean like we got into a fight with somebody. And sometimes people, even in the domain of logic, mean that as an argument, like we're fighting over two things, we're arguing. That's one thing. But an argument in logic, especially in deductive logic, is this. An argument is a series of statements, one of which the conclusion is affirmed on the basis of the others. And so the thing you're going for, like the verdict, is the conclusion. The stuff you use to back up the conclusion, those statements are called premises. So what's a statement? A proposition or a statement is a sentence that can be either true or false. So that can be something that we say, or something that we write down or type up. Something that we can utter in some way, or can communicate in some way, that can be either true or false. So something like Rex the dog is a Dalmatian. And maybe Rex is a dog, but Rex is a pit bull. In which case, Rex the dog is a Dalmatian is false. But if Rex the dog is actually a Dalmatian, then that's true. So a statement is something that can be either true or false. There are some things that we can say that are neither true nor false. And so that's the following four things that I have here. Imperatives or commands are neither true nor false. So if I say something like, go to your room, true or false? Neither. It's neither true nor false. An imperative is not a statement. Now, so-and-so said, go to your room. That can be true or false. Just the saying itself, go to your room, is neither true nor false. That's the case with imperatives or commands. Also, inquiries or questions. Like, if I say, like, is today Monday? True or false? Well, the answer to the question, today is Monday, or it's not, it can be true or false. It is Monday or it's not. But any question is neither true nor false. They're devoid of any kind of truth content in that regard, or truth value. Proposals or suggestions. So if I said something like, let's get a puppy, true or false? Neither. Neither true nor false. Now the answer to that, let's get a puppy. Okay, I say, let's get a puppy. That can be true or false. But the proposal or the suggestion itself is neither true nor false. So imperatives, inquiries, proposals, neither true nor false, and therefore they are not statements in this regard because they have no truth value. And then the fourth kind is fairly obvious. That would be gibberish. So if I say blah, 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 true or false? Nope. The notion of truth value does not apply. So statements are things that can be said that are either true or false. They have truth value. So moving on from there, now we can talk about arguments that are comprised of statements, conclusions, and premises. In deductive logic, an argument is valid if and only if, given that the premises are true, it's impossible for the conclusion to be false. Now, we've already kind of talked about this, so let me also say, too, the phrase if and only if, that'll come up again later in the semester. When we see if and only if, it's almost like an equal sign with words. So what that means is,
if an argument's valid, then given that the premises are true, it's impossible for the conclusion to be false. And if the premises are true and it's impossible for the conclusion to be false, then the argument is valid. That's what that means. So if the premises are true, there's no way the conclusion can be wrong. Like, hey, we've got an object here, it's got three sides, it's a triangle, there's no way that could be wrong. That would be a valid argument. An argument is invalid if and only if, given that the premises are true, it is possible. It might not be, but it's possible for the conclusion or the argument to be false. So that means any kind of induction or abduction is automatically invalid. Now, that doesn't mean we shouldn't listen to it, but it means it's invalid in a specifically deductive sense. All the invalid means here is that it's possible it could be wrong. Not that it is wrong, but that it could be. And so that's what it's meant by invalid here. So you'll hear people drop these words sometimes. Oh, that's a valid point. Colloquially, I'm fine with that. When someone says like a good point about something, like we should do this, that's a valid point. Fine, I wouldn't correct somebody in that. But in a strict deductive sense, something is only valid and only if it's impossible for the conclusion to be false when it comes to looking at logical arguments. And then in deduction, an argument is sound both if it's valid and its premises are in fact true. So there's times where we can have a valid argument where it actually doesn't work in reality. And if an argument's invalid, it's automatically unsound, period. So those are the two criteria that an argument has to be sound. It has to be both valid and it has to be in fact true. So let's take a look at a couple of examples to see what I mean by that. Here's a valid argument. This one I've brought up already. All triangles have three sides. The shape I'm looking at is a triangle. It has three sides, so the shape I'm looking at is a triangle. Valid argument. If the premises are true, if triangles really do have three sides, and the shape I'm observing really has three sides, then there's no way the conclusion here could be wrong. And the shape I'm looking at is a triangle. Period. 100%. No doubt. Valid argument. Invalid argument means maybe, but maybe not. Like it could be, but it doesn't follow with necessity. That means, when I say necessity, that means it has a mustness, or that it must be true. Maybe. Maybe not. So the example I have here, some people win the lottery. True, they do. I'm a person. Yeah, I am. So I'm going to win the lottery. Maybe, but also maybe not. No, it's possible. So it doesn't mean that when I do win the lottery, see, I told you I was right. That means because I'm a person, because I can win the lottery, I told you I was going to win the lottery. That doesn't prove anything. So the fact that it's possible it could be otherwise makes an argument invalid. So sometimes you can have a valid argument, though. It's still unsound because the premises are not in fact true. So consider this one. This next argument is valid because all that valid means is if the premises are true, then it's impossible for the conclusion to be false. It doesn't mean the premises are actually true. So it has this. All sharks are ninjas. All ninjas are wizards. Now, if all that's true, if sharks are ninjas and ninjas are wizards, then it follows all sharks are wizards. That's a valid argument. This is why when people say the word, like they throw around the word valid, it might not necessarily be helpful. This is a valid argument. If the premises are true, then the conclusion follows. But I think we could say it's unsound because the premises are not in fact true. Maybe some sharks are ninjas, but not all of them. And then sometimes, here's another kind of a mistake. We can have an invalid argument where everything that you said to start is true, but the way that you put it together doesn't work. So look, here's an argument where the things that were said at the beginning were true, and the conclusion sounds like it should be true, but it's not. And I think it's obvious here. But what happens is sometimes people make arguments like this last one with stuff that we're unfamiliar with, and therefore it will sound more reasonable. Like, oh, that makes sense. So here it sounds stupid. So if I say all dogs are animals, all cats are animals. Since they're both animals, all dogs are cats. No. I could say all dogs and cats are both animals. That would follow. But say here all dogs are cats. That's stupid. Just because dogs are animals and all cats are animals does not mean that all dogs are cats. It's like a Venn diagram where it's just one circle. So what's happening there is someone's doing something where everything they said is true. The first 2 points are true, and the third point, the conclusion sounds like it should kind of be true, but it doesn't actually follow from the premises. And then, like I said, when people are talking about things that are more technical, sometimes people use this kind of argument and will think it's true. Like if I said, all particular asynchronous axioms are accretions from some point in time t, but also in time t we have accretions that are from the substratum of point B. Well, then what that means is that all substratums are accretions from point A. I just made that up and I used a bunch of technical language and it sounds like it's good, but based on what I said, just in the form, it's stupid. Nothing makes sense from what I just said. And the point I just make is here in the example, it seems obvious, like that's wrong. But sometimes people will use technical, when people are saying things that are technical and we don't recognize the stuff, like with dogs and cats, it's obvious, but in other things, it might not be obvious. So someone might say something that we find confusing. We don't know if there's a mistake in there or not. Just be advised that that's a thing that happens. And finally, we can come to the notion of informal fallacies of logic. So these are informal fallacies in deductive logic. Basically, what I mean by fallacy is some kind of mistake or error that we make in our reasoning. And by informal, I mean that it doesn't have to do with the form. There are formal fallacies, which I'll talk about later in the semester, which are the basic screw-ups of deductive formal logic. These are things that these are mistakes that we can make, especially when we're talking in English or whatever language that we're speaking in, where we can make some logical boo-boos that end up throwing us off. Sometimes they're intentional and sometimes they're unintentional, but I want to go through with them and distinguish them. And all I want you to be able to do here when it comes to the first quiz is be able to know what's what based on the examples. So you'll be able to have the material that I have here open on the screen while you're going through it. I just want you to be able to recognize the example and know this example is an example of what fallacy. So the first one I want to go over is the fallacy of equivocation. This is the illegitimate switching of the meaning of an ambiguous term during the reasoning. So for example, listen to this argument. I say a feather is light. What is light cannot be dark. A feather cannot be dark. That sounds like it should work. Problem here is that the meaning of the word light has changed between the first premise and the second premise. In the first premise, it's referring to weight. In the second premise, it's referring to photons, light in terms of, lightness and darkness. And so it's in English, at any rate, it's an ambiguous term, and I've switched it over the course of the reasoning. This was kind of a silly example, but sometimes if people are using a term that can have different definitions, and people talk about it, then this kind of confusion can happen. This one can happen quite a bit. Here's another one. Informal fallacy. Argumentum ad hominem. Literally, an argument to the man. I prefer like attack of the person. That's not what it literally means. It literally means just argument to the man. That's when an irrelevant attack on the arguer is made that is supposed to suggest that this attack undermines the argument itself. So what you do is you just make fun of the other person. All right, so the example I have here is people who use ad hominem fallacies are idiots. A lot of people use them. A lot of people, just start making fun of other people. Politicians do this a lot. Well, this person's an idiot. You shouldn't trust what they say. Well, maybe, but that doesn't actually have anything to do with the point that they may have been making. You can call someone an idiot all you want. For example, I think the most famous version of this is the story of the boy who cried wolf. He was a liar. He kept telling people there's a wolf there, and there wasn't. And then in the end, the moral of the story is if you keep lying, then when something really happens, people won't believe you. That's a fine moral. But that last time, even though he had lied those first 10 times, that last time, there really was a wolf. Just saying, this person's a liar, doesn't mean that they're lying now. So we need to look at what people actually say and not merely have problems with the identity of the person. There are certain senses in which we can analyze, we can have a probabilistic understanding of this person's consistently lied, so it's probable that they're lying now. But again, not with necessity. So just making fun of people saying, this person's stupid, or they don't know what they're talking about, or they didn't major in this, or what have you. They don't have the background to be able to make this kind of proclamation. So maybe they're wrong, but maybe not. Making fun of somebody doesn't get you anywhere. Similarly, there's the tu quoque fallacy, where you just say, yeah, but you did it. So that's when they're receiving criticism from one view, rather than address the criticism that receiving, brings up something that you did. Yeah, well, you made a mistake. If you've ever had an argument with a significant other or a parent, you've probably had this kind of fallacy before, where you're saying, hey, here's what you did here. This is a problem that's going on. I want to address this. And someone says, yeah, but you did this. The example I have, Anna says eating meat is bad for the planet. Okay, it produces methane and so forth. But she eats meat, so I guess it must not really be bad for the planet then. I get what you're trying to do. You're trying to make fun of Anna's inconsistency, but that doesn't negate her point. Even if she's inconsistent on it, or she did something where she made a mistake, That doesn't mean that she's wrong just because she's inconsistent. This is another form, basically, of ad hominem, where you're making fun of somebody. And another form of ad hominem is the straw man fallacy. This is where you attack a misrepresentation of your opponent's view. So you say, oh, these people believe this. So you construct a made-up version of what somebody's saying, where it's not really what they're saying, but a made-up version. And then you basically try and beat it up, and you're like, I beat them. But no, you didn't beat them up. You beat up the mannequin version of their argument. So consider this. I've heard this one before many times. Charles Darwin said that humans evolved from monkeys. Yet there are still monkeys, so the theory of evolution is obviously false. What's the problem here? It's a misrepresentation. It's a straw man fallacy, because nowhere did Charles Darwin say that humans evolved from monkeys. He would say that apes and monkeys share a common ancestor with human beings. So they have a shared common ancestor. He never anywhere said that we evolved from monkeys. That's a misrepresentation of Darwin. So that's the problem here, is that you think you've beaten something by not talking about it or not articulating it correctly. These next two fallacies are very similar. Secundum and Simpliciter. They're both fallacies of generalization, where you take a group phenomenon and basically screw it up somehow. So in secundum, which is sometimes called a hasty generalization, it comes from a Latin phrase, addicto secundum quid addictum simpliciter. Basically, you take one statement that works to something where it doesn't work. Okay, that's where you take a couple of instances and you say this must be the truth. So consider this argument. It rained on my birthday this year. It rained on my birthday last year. Ugh, it always rains on my birthday. What's wrong with this? Well, maybe if you're 2, this works. That is 2 years old. But I know it can feel that way, like something always happens. You say, you know, people do this all the time when like they get stuck in traffic. Oh, I always hit a red light. Probably not if we added up every single instance. But what you do is you take a couple of instances and you try and generalize from those instances, and you say, therefore, this rained on my birthday last year. It rained on my birthday this year. It always rains on my birthday. Well, what about your other birthdays before that? Now, if we could come up with a comprehensive list where every single time you've had a birthday it always rains, then maybe we could say that. But then we still don't even know from your future birthdays. Will it always rain on your birthday? Okay, even after you're gone. So that makes this, that's a secundum argument, where you take a couple of instances and you say, well, from these couple of examples, this must always be true. And this is also the stereotyping fallacy. That's literally what's happening in stereotyping. Like, these couple of instances were true, and then you take these couple of instances and you say, well, therefore, from these couple of instances, it's always true. Nope. Secundum fallacy. Simpliciter, this one's rarer, but occasionally happens. I just want to bring it up. It's kind of the inverse of that. So simpliciter is short for addicto simpliciter addictum secundum quid. And what happens here is basically one takes a general rule of which there's an exception and then tries to stuff the exception into the rule. So, for example, listen to this argument. Birds can normally fly. True. Tweety the penguin is a bird. Hint. Penguins don't fly. So I say Tweety the penguin can fly. No, Tweety the penguin cannot. Because penguins are birds. Not all birds can fly, but I've already said birds can normally fly, so, well, because birds do that, then this bird must be able to do that, so that's what all birds do, right? So this bird should be able to fly. Doesn't work here, and the fallacy is the simpliciter fallacy. So the next fallacy I want to go over is Argumentum Ad Ignorantiam, or argument from ignorance. So what happens here is not knowing that a statement is true is taken as proof that it's false, or not knowing that a statement is false is taken as proof that it's true. In short, absence of evidence is used to justify evidence of absence. So consider this version. While it has been proved that the surface of the moon is not made of green cheese, people used to think this for some reason, we have not proven that the core of the moon is not stuffed with barbecued spare ribs. Therefore, hey, the moon is stuffed with barbecued spare ribs. And if you're like, that's ridiculous, well, you can't disprove it. How do you know they're not there? Argument from ignorance. That's the fallacy. Like, maybe we'll dig into the moon and we will find that it's stuffed with barbecued spare ribs. But just saying that you haven't disproven it doesn't make it true. Where this happens is often in theological arguments. Someone will say, hey, you haven't proved that God exists. God doesn't exist. Argument from ignorance. But also, you can't say you haven't proven that God doesn't exist. So because you haven't disproven it, therefore he does exist. Both of those would be arguments from ignorance for the exact same reason. You're taking like the fact that something hasn't been proven or disproven as making it obvious that the opposite case is true. And that's an argument from ignorance. There might be good arguments to get you there, but that, as it is, does not get you there. That's the problem with an argument from ignorance. It's not what is being said is true or false. It's that this argument saying, well, you haven't disproven it, or you haven't proven it, just saying that doesn't make something true or false. Next one. Argumentum ad Verecundiam is appeal to authority or argument to the respect. This is where you say, because someone's authoritative in something, they must be authoritative in something else. So there are legitimate reasons to actually use this. So let me explain how the fallacy is different from appeal to authority. So like if I'm looking at something in biology and I'm looking at what renowned biologists say, this is not an example of this. Or even if I'm looking at something in theology and I say, historically people have said in theology this, I'm looking at authorities. But if I say, oh, you know what, here's something in social psychology that my mechanic said. Now listen, the mechanic might not be wrong, but just because they're an authority in one thing does not mean they're authority in another thing. We see this a lot where celebrities will say things about politics, maybe. All right, just because someone's a celebrity, just because they're good at acting and they're good at music, it doesn't necessitate just because somebody's popular in something that they must necessarily be good in something else. If your physician says something, take their advice when it comes to stuff that has to do with your health. If your psychologist or your psychiatrist says something when it comes to your mental health, listen to what they say. If your mechanic says something with your mental health, maybe they're right, but just because they're your mechanic doesn't make them right because of that one expertise in one thing. So again, the fallacy here is the misapplication. Just because, oh, this person's good in this thing, they must be good in this other thing, necessarily. They might be, but it doesn't follow with necessity. The next two are kind of cousins of each other. Petitio Principii and Circulus in Probando. Both of these are examples of circular reasoning, where you're basically saying the same thing twice. I distinguish between them by saying begging the question or Petitio Principii is where you've already proven what you want to say, therefore you're not proving anything, and it's kind of implied. You're kind of hiding it in begging the question. So, like, consider a defense attorney saying this. The defendant, my client, is innocent of the crime. You ask, why are they innocent? Because they're not guilty. If they're not guilty, then we might have other evidence to support that. Like they might have an alibi, they might have, other kinds of evidence saying what else is going on. But just saying my client is not guilty because they're innocent, and they're innocent because they're not guilty. I'm just saying the same thing in different ways. I'm kind of twisting or hiding, but I'm saying the same thing, so therefore it's implicit. But that's what I'm doing. I'm arguing in a circle. I haven't said anything new. I haven't proven anything. I've just kind of said two different things. That's begging the question. We use the phrase begging the question to mean like it makes us think about asking this question. That's something that we say, but that's not the fallacy. On the other hand, Circulus and Probando is where literally circle in the proving is where we're not even trying to hide it. So we say something like this, and maybe your parents use this one on you where they said, because I said so. Circular reasoning. I'm not saying that when your parents say that, go ahead and say, you're committing a fallacy. Not wise, don't do it. But if someone said something like this, murder is morally wrong because it's wrong. So it's wrong. It's wrong because it just is because it is. Circular reasoning, and there it's explicit. I'm not even trying to hide that I'm arguing in a circle. Something's wrong because it's wrong. It's right because it's right. It's good because it's good. It is what it is. All that circular reasoning, because I'm not even trying to do a little bit of a switcheroo like I did in begging the question. I'm just saying the exact same thing over again. And therefore, the problem with it is, or the fallacy is, the thing I'm trying to prove is what I've already assumed, and what I've assumed is what I'm trying to prove. So I haven't got anything new, I've just argued in a circle. Let's look at false dilemma. This is where one presents a dichotomy, or like a false choice between two scenarios. Now, we could have a false trilemma, we could have a false quadrilemma. This is where someone says it has to be one or the other, or some other option. Like, here are the options when other options are available. So let's say Bob went down to the corner store to pick up some Miller High Life. And then Bob's missing, which we haven't heard from him in an hour. And so we go, Bob's dead, or he's been abducted by aliens. And let's assume, for the sake of argument, that both those things are true. Maybe he is dead. Maybe he got into an accident on the way home. Maybe he has been abducted by aliens. Or literally anything else. And so that's what a false dilemma is. A false dilemma is where you say, like, well, it's got to be one of these two things happen. Or something else. Next one, Argumentum Ad Logicam. And this one's similar to the Quoque from earlier too. This is where you say, hey, someone else committed a fallacy, so I don't need to listen to what they say because they messed up. They made a fallacy, so automatically everything they said is wrong. That doesn't follow. Someone can make a fallacy and still be correct in what they're saying, even though they made a mistake getting there. Okay, so consider this conversation. Carlo says, you cannot borrow my car because it turns back into a pumpkin at midnight. Evelyn says, if you really think that, you're an idiot. Carlo says, that's an ad hominem fallacy. So that means I can't be an idiot because you're wrong, and when you're wrong, it means I'm right. Evelyn says, I beg to differ. So yeah, just because someone else makes a logical mistake doesn't mean that because they made a mistake, therefore everything that they said is wrong. they made a mistake in getting there, but that doesn't mean that the conclusions are mistaken. Like if I said 2 plus 2 equals 4, therefore today is Sunday. Well, today is Sunday, at least at the time of me recording this. That doesn't mean that that argument got me there, but just because someone made a mistake, or let me say 2 plus 2 equals 5, therefore today is Sunday. That's not true, so today can't be Sunday because you messed up. Nope, that doesn't follow. Ignoraio Elenchi. Literally that means irrelevant conclusion. This is where you bring up something else altogether. It has nothing to do with what's going on. It might seem like it in the moment. Like, consider this conversation. Sydney says, ask the question, is it illegal to park here? And Jennifer says, it should be. Maybe it should be. But is it illegal to park here? Yes or no? Someone's brought up something else. This happens a lot when people ask like a moral question, like, oh, someone did this in this situation. Is this the right thing to do? And someone says, well, I would do it in that situation. Okay, you would do it. That doesn't answer whether or not it's right or wrong. It's completely irrelevant. And whereas the others that I've mentioned have had Latin phrases, that's actually a Greek phrase. Let me also be clear here with the informal fallacies. You don't have to memorize the Latin or the Greek phrases. I just want you to recognize the examples. Next two are similar to each other. Argumentum ad Antiquitatem, literally the argument to the old, literally appeal to the antique. This is where you say, well, just because we've always done something, we should be doing it that way. So the example I have, people have been learning how to write cursive long before we started typing all the time. Therefore, the education system ought to spend more time and energy on cursive instruction. This is something I could not disagree with more. When I was in elementary school, we all had to learn cursive. Is it important? I don't see how. The only reason I can think it's important is to then figure out how to read cursive in historical documents. But since so much of the way that they wrote cursive, say in the Declaration of Independence, is very different from how we learned cursive when we were younger, it's really not that helpful. You go back even further to the 17th century, where S's in the middle of words look like F's and you get very confused. It's really not helpful. But just saying, well, basically we've always done something this way, so we should always do something this way because that's the way we've done it. Maybe a more tactile example of this would be like, oh, the way that you put the dishes in the dishwasher is the way that it has to be done. And someone else, your partner, puts the dishes in the dishwasher differently. You say, can't do it that way because it's different. So it's wrong. Argumentum ad Antiquitatem. A similar argument would be Argumentum ad Populum. And this one is sometimes called the bandwagon fallacy. This is the peer pressure fallacy. This is because a bunch of people are doing something that therefore it makes it true. So in this one, the example I have, and I'm thinking of a news commercial for the local news. Channel 6 is the most watched news channel. So you picture the meteorologist like looking at the weather and then laughing. Sportscaster catching a football, then laughing into the camera. The newscaster like shuffling papers right before they say something. And then it says, you should watch Channel 6 News. Maybe we should, but just because everyone's doing it doesn't make it true. This one is kind of grounded on the principle that sometimes people say, like, no, millions or billions of people can't be wrong. Yes, they can, and they often are. But just because a lot of people are into something doesn't mean that something is true. Next one, Argumentum ex Silentio. This is an argument from silence. And this is just because something is not said, we assume that because they didn't say so, it must be true. So this happens sometimes in courtroom cases. And here's the example I have. A detective and a suspect are talking. The detective asks, did you murder the victim? The suspect doesn't say anything. Well, you didn't say no, so that means you're the murderer. Is it possible? Sure, it's totally possible. Does it follow with necessity that because someone doesn't say anything, like when I ask, are you the murderer? And you say no? Sometimes this can be related to the fallacy of, which I don't have articulated here, but the fallacy of a loaded question. Let's say if someone is very peaceful, hasn't ever done anything, and a detective asks you, so how long have you been beating your wife? And you go, and you don't say anything. Oh, so I guess you must have been doing it for a long time. So argument from silence is where you say just because someone didn't say something, it must be true. So if I asked you, hey, were you here last semester? And you say, I go, oh, then you must have been. So you know all the policies and everything. So you know what's going on because you didn't say otherwise. Argument from silence. Watch out for that one. Don't mix it up with the argument from ignorance. A little bit different. So go back and look at that one too to make sure you don't mix those up. Now, for the purposes of the quiz, you just need to make sure you know the examples. Argumentum ad Misericordiam. Literally, argument to misery or pity. This is where you support a conclusion by making someone feel bad. So this is emotional manipulation. So someone might do this to me. Please don't do this. But I've had this happen before. So let's say someone says, if I don't make an A in this class, I won't graduate. I won't be able to find a good job. So I deserve an A in this class. Listen, maybe you do from the work that you put forth. Just because you're trying to make me feel bad about it doesn't make it true. So if you've ever heard someone say something like, if you really loved me, you'd do this. Please love me. If you really love me, you do that. Argumentum ad Misericordiam. That's what it is. Don't fall for it. These next two are very similar. Fallacy of Composition and Fallacy of Division. They're basically inverses of each other. Fallacy of Composition is where you say that what's true of a part is also true of the whole. That doesn't always work. So listen to this argument. Atoms are not visible to the naked eye. You can't see them. You can't see electrons, protons, like a hydrogen. Even if you're looking at water, like I'm looking at a bottle of water right now, I don't see the hydrogen atoms floating around. I just don't. Okay, because they're not visible to the naked eye. But then I say something like, oh, people are made of atoms. They're comprised of atoms. And then I say, well, wait a minute. Atoms are not visible to the naked eye, but people are made out of atoms. People are invisible. Fallacy of Composition. So what's true of the part is not necessarily true of the whole. Then Fallacy of Division is kind of the backwards version of that. What's true of the whole is not necessarily true of the part. So I say here, the city of Aiken, South Carolina has several golf courses and horse tracks. It does. If you look at a map of Aiken, you'll see all these little circles for horse tracks. You see all these little splotches of green. They're either places for horses or places for golf. We got a lot. We say, here's Abby. She's someone who lives in Aiken, South Carolina. And you've seen this kind of stuff happen before where someone says, oh, you're from Aiken. You must love golf. And when's the last time you rode horses? And Abby says, I don't do either one of those things. Maybe she does. But to assume just because she's from Aiken and golf and horses are big in Aiken, that she therefore does these things, that doesn't follow. Just because what's true of the whole of Aiken, like Aiken is a town that's all about horses and all about golf, doesn't make it true of the individual components or citizens who live there. Doesn't mean that everybody plays golf. It's like USC Aiken's in Aiken. Doesn't mean everybody's a student at USC Aiken. That doesn't follow either. That would be a fallacy of division. These next two, very common. Slippery slope and post hoc ergo propter hoc. Slippery slope, this is where one assumes that if something happens, then something else will happen. So you should not do the first thing because the second thing will happen. But what makes a slippery slope is where you say you don't say how they're connected. So it's perfectly legitimate to say, hey, if we do this one thing, it will lead to something else. That's not slippery slope. But I'll hear people say this all the time. People will say one thing, go, slippery slope, it'll lead to the other thing, without showing how it leads to the other thing. So sometimes people will say something like, I don't know, people paying less for their prescription drugs, slippery slope to communism. Maybe it is, but you haven't showed how those things are connected. And that's what the slippery slope fallacy is. So here's an argument I've heard before. If homosexuality is normalized, which was in the past considered a deviant behavior, if you look at the DSM-2 in the history of psychology, it was considered a deviant behavior. It's not now, nor do I think it should be, but has been considered that in the past. Someone says if homosexuality is normalized, bestiality will eventually become normalized and legalized. So homosexuality ought not be normalized, because if that thing's allowed, then the other stuff will be allowed. That doesn't follow. You haven't, and the reason why it's a slippery slope argument is you haven't shown how one thing leads to another thing. Maybe it will. I think it's a ridiculous argument. But someone might say, this one thing leads to this other thing. Well, show me how it gets there. So the slippery slope fallacy is simply you don't connect the dots. That's the problem. It's not that you say one thing will lead to something else. It's that you say one thing will lead to something else without showing how. That's what makes a slippery slope a slippery slope. And then post hoc ergo propter hoc, sometimes post hoc ergo propter hoc, depending on how you want to pronounce your Latin. This is where, sometimes this is called after this, therefore because of this. That's literally what the Latin means. Sometimes this is called correlation does not equal causation, especially in the social sciences. This is where you assume that if one thing happens, and then another thing happens, the first thing must be the cause of the second thing. Listen to this argument. The number of pirates in the world has decreased over the last 4 centuries. Now, when I say pirates, I'm talking classical pirates, wooden leg, eye patch, parrot on the shoulder, pirates of the Caribbean. There are fewer pirates in the world today than there were in the past. Also, last 4 centuries, the temperatures in the world have gone up. So I say, this thing happened, the temperature increased, they must be connected. So I say, pirates cool the earth. The number of pirates went down, the temperature of the earth went up. There must be a connection. That's the fallacy. You say there must be a connection. And so here, correlation doesn't equal causation. You take two things that happen in the world and you say they must be connected somehow, even though you have no way of demonstrating their necessary connection. Maybe somehow pirates do cool the earth. Maybe they do, but you haven't proven it. And that's what makes these informal fallacies fallacies. It's not that your ultimate conclusion is wrong. It might be true. It's that it doesn't follow from what you're saying. It doesn't follow with necessity from what you're saying. No true Scotsman. You basically keep coming up with a special, your own version of a definition to make something work. So consider this conversation between Elijah and Brianna. Elijah says, hey, are you a fan of Michael Jackson's music? And Brianna says, oh yeah, I love Thriller. And Elijah says, oh really? If you're such a fan, then name every song on the album Thriller. To which Brianna responds, let's see, there's Thriller, there's Pretty Young Thing, there's Billie Jean, there's Bad. And Elijah says, nope, Bad's not even on that album. It's on the album Bad. And Brianna's like, well, that's all I can think of. And Elijah says, well, you must not be a real Michael Jackson fan because you obviously are not able to tell these albums apart. Well, and Brianna says, I am. I know all the lyrics to these songs. No, Elijah says, a real Michael Jackson fan would have been able to list every track on that album in order. According to whom? Well, according to Elijah. So what Elijah's doing is coming up with a special definition here of what it means to be a Michael Jackson fan. So people say, in order to be a fan of something, you got to be able to do this, 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 and this. Okay, whether it be music, whether it be sports, whether it be art. Like, oh, I like Van Gogh paintings. Oh, yeah? Name 10 of them. Oh, I don't know if I could name 10. Well, then I guess you're not really a Van Gogh fan. All right? Or, oh, are you? Oh, I see that you're wearing an Atlanta Braves hat. Can you name any member of the Atlanta Braves before 1996? Can you name their averages? Oh, you're a Colts fan. What was Peyton Manning's passer average in 2006? Oh, you can't do that? Then I guess you're not really a Colts fan. All that kind of stuff right there. No true Scotsman. Because what you're doing is you're saying, oh, a specific definition of what I think it means to be something, well, it must be that thing because I said so. Not because of any definition that exists out there, but simply because you said so. This comes up a lot in terms of gender debates. Oh, here's what it means to be a man. Okay, think tough. Don't cry. That's what it means to be a man. According to whom? Me and my dad. Men don't cry. Well, I know a man and he cried. Well, then he's not a real man then. No true Scotsman fallacy. You're taking a definition that you kind of made up and you have no real reason to stick to it, but you keep sticking to it just because. And that's what the fallacy is there. So again, with all these things, with the fallacies, the examples that I have, what I want you to do for the quiz is be able to recognize the fallacy. So if you saw that one, this conversation between Elijah and Brianna, I might say, well, was this example of A, equivocation, B, no true Scotsman, C, composition, D, Antiquitatem, and you go, hey, this is an example of no true Scotsman. That's what I expect you to do here on that first quiz, not to commit all these to memory. What I'd like you to do practically is to, when you next time you look at people saying things, is to apply these. But at least for the grading purposes of this course, I want you to be able to simply recognize the examples and what they refer to.